What if you wanted to create a TCP server and all you had to do was this? You select the port, choose a function which is going to run every time someone connects. Then you can just check if it's succeeded. Otherwise you can use this error function to print an error. And then you just run listen. And this is the entire main function for a TCP server. And inside of the handler function, the one that's going to run every time someone connects, you just send data and you receive by using the receive function. And when you return from the function, the connection is disconnected. So this is what we're going to create today. Let's get started. Sup guys, welcome to today's show. So today I want to create a small project, but it's gonna be a TCP server library, and I want it to be beginner friendly. I want to make it very easy for any C programmer to create a TCP server. I will only have one exported function. Let's say we have a variable called serve, and we set it equal to TCP server. And this is going to take two arguments. So the first is the port number. So let's say 8080 or something. And the second argument is a function, and it's going to be called like this. So we will have a function called handle, which will take care, so every time someone connects to the server, this function will run and take care of that connection. So the only thing the user of this library, the programmer, needs to do is create this function handling the connection and specifying the port number. And the underlying library will take care of setting up everything, making the process go into the background, listen to the port and everything. And then you will just use a method of this serve object. So if serve returns true, so it was successful, then we will do something like serve, I don't know, listen or something. And that's it. Then this function will handle the main loop and everything. And this is the whole main function, basically. And this serve needs to be some, let's say we have a variable type called server. So that's the general idea. So it should be beginner friendly for using the library as a programmer. The project itself is going to be beginner to intermediate. And it's going to be a small project, so only these two functions basically, maybe some utility functions that the programmer will not use directly. And I want this project to be a one episode project. So after this episode, it should be done. That's the general idea anyway. I hope I will succeed in that. And this could be a great project for your resume or whatever. Alright, so let's see. I'm gonna create 3 different files. And we will not be using any dependencies or any libraries, not even my own. So, and I'm just gonna call this project TCP server. So we'll have a TCP server.c. like so. We are going to have a TCP, no, a TCP server dot H, and a very simple make file for compiling everything. So basically I will just do something like, so we want to create TCP server .o from TCP server.c, and I want to run GCC TCP server.c -o TCP server. And this is temporarily, because I will not create a regular executable when we are done with this project. It's going to be a library, but this is during development. So when we have, by the way, we can even do, let's see. I think I want to have a possibility to add some flags at least. So we'll add this variable here. And I'm not gonna do it like, not gonna do it like this. I'm gonna do -c TCP server dot C. So we create an O file, and then we will have the actual executable, which will just run GCC with the flags. It's going to need a dependency of TCP server.o. So TCP server.o is going to be TCP server. And all is going to run TCP server. And we'll have a clean, which will just remove the O files and TCP server binary, like so. And just one more thing, we need to set this flags variable. Let's set it to optimizations and extra error messages. All right, simple enough. And our C is going to include our O. So I will do, well, I guess we will do this, TCP server.h. And then we need to modify the make file and add that our includes should be from the running directory, like so. And inside of here, I'm going to include as little as possible, but I at least want to have some stuff during development at least. stdlib as well. And I'm going to create some integer types, as I usually do. So we're going to take the unsigned char, which is our int8, our 8-bit integer. I'm going to have an unsigned short int, which is an int16. Unsigned int is int32. Unsigned long int is int64. And then I'm going to create my regular typecasting macros. So this is going to convert to a char, this to an integer, and then we have the 1 byte, which is an int8 star. We have a 2 byte, which is an int16, and we have a 4 byte, which is int32, and an 8 byte. I don't think I'm going to use that, but let's have it for completeness. Okay, since we're going to create a library, we also need to define what we're going to export and not. So I need to create some, well, we're going to have a public, which sets an attribute. And this is, let's see if I remember how to do this, visibility. Like this, I think. So visibility, either it's hidden or it's let's see, grep public. So maybe we have it inside of S. No, not inside S. Well, maybe. I think we have it in our ping. So ping.h. No. Visibility default. All right. And then we have private. And that is hidden. It's hidden and it's static, I guess. And we need to have those underlines on both sides. Okay. So we're gonna have, let's see, we're gonna have temporary main function, and I will indicate that by doing a space in between, in before. And let's not have any arguments to this. And then we are going to have a public function which is going to return a server pointer, and it's going to be called TCP Server, taking 2 arguments. One is an int16 for the port number, and one is a callback function. So we need to define what a a server data type is and what a callback data type is. So let's define that. So we're going to create a structure. So struct s server. And we need to have int32 for the socket file descriptor. Let's call it fd. And we're probably going to need some other stuff as well, but let's start there so we have something. And we're going to type def this, struct s server, and this is going to be a server, like so. And what about the callback? That's going to be a function. So let's first define an example function. So let's say private, I don't know, temp. So what do we want to have as arguments here? I guess it would be interesting. Let's see. Yes, if we could have another structure. So struct s, let's call this connection. And it too is going to have a socket file descriptor. It's going to have an IP address. And how are we going to store that? I think actually that I want to store this as a string, just to make it easy for the user. So let's say this is the host. An IP address needs 16 bytes. Let's also provide the port number, the local port number that is. What else? Well, that's enough for now. So we're going to type def this, and let's call this connection. So our temporary function is going to provide this connection as an argument, so a pointer to a connection. And I think that will be all we need. Yeah. So how do we define a function pointer for this? So it's going to be something along the lines of let's see, what do we want to return? Don't think we need to return anything. So let's make this a void. And this is a callback. And we're going to have one argument, which is a connection. So I think this will be the syntax. Something like this. All right, that's enough preparations. Let's start the coding. So we'll have a simple main function, and here we want to have a server serve, which is going to be equal to TCP server. And we need a port number, let's say 8585. And we need a callback. And I'm not sure why I want to do it like this, but I do. So let's say we have a callback like this. So private void callback function. We can call it a handler prime, and it's going to take a connection. Connection con, something like this, and I'm gonna have a function definition. A function-based macro, which I'm going to call handler without arguments, and that is just going to return handler prime, like so. And then I can say handler like this. All right. If we don't have a serve, we will print an error message. Let's just do this. Error. Maybe we could do something like this instead. So if serve OK, then we will print error and then an error message, which we get from serve.r. That's quite nice. Something like this. If serve and serve OK. Serve not OK, I mean. Okay. And if we get this far, we can print something like listening to port this. '85. And then we'll just do return serve dot listen. All right, this code is pretty simple. I think most will understand this code. And that's the general idea, that this library is going to be very simple to use. Right? So how do we make this work? The first thing we need to do is this TCP server function, which will set up everything. And that's going to be the most, the function which is going to be most difficult to understand for beginners, but it needs to be done in a certain way, and so we can't get around that. But the rest of the code will be pretty self-explanatory. So let's see here. So we're going to have a public function which is going to return a server pointer. TCP server. It's going to take an int16 port and callback CB. Something like this. So the CB is the function which is going to run when we get a connection. All right, so how do we set this up? We need to have a couple of things. First, we need to have a signed integer for the return values. So let's call this ret. And we need an int32s for the socket file descriptor. We need to have a struct sock address in sock. Okay, so in order to set up a incoming TCP connection, we need a couple of things. First, we need to run socket, so we get a socket file descriptor. Then we want to run bind, which in this case connects this socket file descriptor to a specific port number. Then we want to run listen, which will listen on the port, and then we want to run accept in a loop. So accept will wait for an incoming connection, and when it happens, it's going to return a file descriptor for the new connection. So we'll have one for the listening connection or listening socket, and then we will get one for each connection, and then we will dump this over to our callback function. So like the handler in this case. All right, so we need to do these things one at a time. So we're gonna set our ret equal to socket. This is going to be an internet socket, sock stream, which is TCP, and the last argument, which is just 0. And if this ret is less than 0, in that case we want to return an error. And let's say that error is failed to initialize socket. And we need to create this return error macro. Let's do it now. So what does this return error need to do? Well, it's going to return, and it needs to return a server pointer. So we need to allocate an object like that. And we need to somehow tell it that it has failed. So our server object needs to have some kind of, let's see, let's say we have an int8 status, and we also need to have an error message. So let's do it as an array. So error message like this. And the status, we can make this, what's it called? An enum. So let's, never mind. Let's define it up here. Or let's do it here. So we need to have an enum. We can make it an anonymous enum like this, where we're gonna have a error status. Okay. Okay status. Those two. Right. So we actually only need to have, well, we only need to have one bit. Okay, so we need to create the macro for the errors. So return error is going to take an X, which is our error message. And let's do the while, the do trick. So let's see here. We need to allocate one of these objects. So we need to have a server. Let's call this serve. Serve like this. Serve is going to be equal to, well, we need to calculate how big this thing is going to be. So let's say int16 size, where the size is going to be equal to the size of a struct s server plus the length of the error message. So the int16 version of the string length of x like this. Plus 1, right? And serve is going to be, we need to do this. And serve is going to be equal to server, and we will allocate size bytes. And we can assert that we have a serve. And let's clean it out so we can use memset. So we want to set our serve structure fill it with zeros and size number of zeros, like so. And we want to take this serve object and set the status to error status. And then we need to copy the error message. So we can do a mem copy. We need to copy it as a char into our serve.error message. We want to copy from the char of x maybe we should save this. We create one variable for the length as well. So we can set let's do this. And let's say length is equal to this. So we can reuse it here as an integer. And that's pretty much it. So now we just return this serve object. And we don't want to loop, so we will do while false, like so. I think this is going to work. At least it should. All right. So at this point we have a socket. Now we need to initialize a structure, the sock structure. So it knows what IP address and port, etc. to bind to. So we're going to set socks in family to AF inet. We're going to set the port to, and we need to turn this into network byte order so we can run hton s on the integer version of our port. And we will have a SYN address, source address, which is going to be in address any, which is a constant which listens to every IP address. And now we need to bind them together. So let's set our return variable to bind, and we will provide the integer version of our socket file descriptor. we will cast into struct sock address, and we provide our sock pointer or reference, and then we have this length thing. I never really remember how to do this, but I think we need to do something like just size of struct sock address. Maybe something like this. Alright, and this should return 0. So if our return, and by the way, if we do get a socket, we need to set our S equal to the int32 version of our return, because we are overwriting it here. So if our return is not 0, in that case we want to close down our S, and we want to return an error of unable to bind to port. Okay, so the next thing is to listen to the socket. What are the arguments? I think I need to check the manual actually. Man to listen. Okay, so the FD and the backlog on success 0 is returned, all right? So the socket file descriptor as an integer, and then the backlog, how many incoming unhandled sockets do we want to queue? And this is not really necessary in our case since we'll be accepting all of them, so let's just say 10 or something. And if this returns positive, we want to close down our socket, return an error, unable to listen to port or something. All right, so the only thing left is to accept the connections, which we need to do inside of a loop. So let's create another set of those things. So we need to have a socket file descriptor for the incoming connection, and we need to have a socket structure as well. So let's call this the scli for client, and this is the client. Right, so at this point we want to run, by the way, we want to, let's see here. We don't want to accept the connections at this point, by the way, because we want to run this listen for that. So at this point, we just want to return one of our structures. All right. So we're going to have a server, serve, and an int16 for the size. Size is going to be equal to size of struct s server. And we don't need to add any extra here for the error message, since there is no error. And if there will be an error at a later point, then we can create a new structure. All right. So let's allocate for this. So our serve is going to be equal to malloc of size, and we can actually assert or no. Let's do some. Yes, by the way, let's do assert serve. Because if we get a memory error at this point, all bets are off. Okay. Then we want to memset this thing. 0 size. And let's just fill in the fields. So we need to have an FD, a status, and an error message. And the error message should be nothing. So we're going to take this serve and its file descriptor, which is going to be our S, and the status is going to be By the way, let's save the port as well. The status is going to be OK status. And then we'll return serve like so. Okay, so now we have this figured out. So what else do we need? We need to have this OK and this R. This R method. So let's create those two functions. We can make this private. So we're going to have a private. I think we can make them private. Since we're going to use them as methods, I don't think we need to publish them. We'll know when we try it. All right, so let's call this, I don't know. We need a boolean. OK function. Void. And we need a private void, no, not void, a private char r message function. Or what did we call it? We just call it r, that's good. So r function. Like so. And in order to keep track of our server object, we need to have a global variable for that. I don't really like global variables, but it's not really possible in any other way. So let's see here. This is going to be a server object. Let's call it global serve. And it needs to be public. And we need to have some kind of initialization function. So let's say we have a private void start. And it needs to be an init function, which we need to define. And that's some kind of attribute. I think it's like this, if I remember correctly. So this function is going to run when this library is loaded or initialized. So private init start. And the only thing we're going to do here is setting our global serve to server 0. And when we run our TCP server, we want to make sure that this is not occupied. So if we have a global serve, which is not 0, we will return an error. Something like this. And before we return here, let's set our global serve to serve. Okay, so now that we have a global variable, we can create these two functions, our OK function and our error function, because it wouldn't be possible to find the server object otherwise. So private bool. By the way, if you're going to use booleans, we need to include something. Include std bool .h, and if we want to use assert, we also need to include some stuff. We need assert.h, we need our number.h, and we need to define GNU source, like so. So private bool something, what did we call this? OK function. And let's first check that we have a global serve. So if we don't, we will return false. Otherwise, we want to return based on the global serve status. So if this is equal to OK status, in that case we want to return true, otherwise false. This is the whole function. Then we need something for the error message. So private char error message, no error function. Same here, if we don't have a global serve, we can return a string of TCP server not initialized. And if our global serve has a status which is not equal to error status, I think we call it that. Yes. So it's not equal to error status. In that case, we want to return no error. And otherwise, let's return the string version of global serve error message. Simple enough. Now we just need to link those as methods to this right here. So we will have a function pointer, so bool OK, void I think this is it. Then we need to have a char r, also void. So two function pointers, which we need to set when we initialize this. So our serve.ok is going to be our OK function, or it's going to be the address of our OK function. Which reminds me, we need to do the same here, the address of our handler. And our R function is going to be the R function. Okay. So almost done. What we have left is our listen function. So private and for convenience, let's just return a regular integer. So private int listen function void okay private int listen function. So what are we going to do here? First, we need to check that we have a global serve. If we don't, we need to return an error. Let's just do this. So actually, we don't need to have those extra variables here, since we will do this in another function. So let's create an int 32s signed int ret struct sock address in sock. And I think we need to have something for the size. Let's check the accept function. So let's see here. Address length. We can leave this 0 as is specified here, but if we do, we will not get any information about the IP address and stuff of the connecting thing. Okay. Socklen T. Socklen T. So let's have a sock length. Well, just let's call it len. And let's also have a sock len T star len pointer. It's not strictly necessary, but let's do it. Let's also check that we don't have an error condition. So else if global serve dot global serve status, if this is equal to an error status, we'll also return -1. Otherwise, we should be able to start accepting connections. So first of all, we need to fork into the background and exit the main process. So let's see here, if fork is 0. So what fork does is it splits this running process into 2. And if fork returns 0, we are dealing with the main thread. So I want to exit the main thread. So all the code down here is the child process, which is in the background. And that's the point. We want to run the server in the background. But we do also want to fork as soon as we have accepted a connection. So let's set our length to the size of a struct sock address in. And our len pointer should point at our len. Then we want to loop. Forever. We want to set our return to accept. And we need to provide the global serve file descriptor as an integer. We need to provide struct sock address sock, and we need to provide our len pointer. And if our ret is equal to 0, everything is okay. Otherwise, it's an error. So if ret is positive, that means that this accepting of the connection failed. And if it fails, it's very possible that the next will fail as well, and this will be an endless loop which will go over and over very fast. So I usually like to do a sleep here for let's say 2 seconds, and then we can try again, accepting the next connection. Something like this. Okay. Otherwise, the connection will be established at this point. So what we want to do now is we want to create one of these connection objects and pass it to our handling function, our handler. So let's create an int16 size. We also need to have, what do we call these objects? Connections. So a connection con. So our size is equal to the size of a struct S connection. And then we will allocate for it. And if this fails, in that case we want to close this connection. Let's see. What's the return value of accept? I think I made some error here. Yeah, it returns a file descriptor on error -1. Good that I caught that. So if ret is less than 0, then we want to do this. Otherwise, we want to set our s equal to ret. Right, so let's close down this connection. Let's sleep for 2 seconds and let's continue. No, wait a second. Yeah, let's continue. And this size is not going to change, so let's put it outside of the loop. Otherwise, we can clean this out with memset. And now we just need to fill it out. So we have an FD, we have a host, and we have a port. So the FD is our S. The host is, let's see here. We have something called inet address for turning an IP address as a string into an integer type. And now we need to do the other way around. What's that called? Let's see here. inet NTOA. Is that it? Deprecated. So what are we going to use instead? Is it this thing, a struct thing? Struct in address. Why do they need to remove all the good functions? Maybe we can use it anyway. So inet NTOA TY, and we provide struct in address. Struct in address. I think that is our sock dot syn address. And then we have the port, the local port number for this connection. Guess we can just run hton-s on it again. Sock syn port. Something like this. And now we want to pass this to our handle function. So let's see. Okay. We provide the handler at this point when we run the TCP server function. So we need to store that inside of our object. So here we need to have a function pointer. So handler, or what did we call it? Connect, callback. Let's call it CB. And let's not forget to set that. Here we have a CB before we return. So our serve CB is going to be CB. Okay, so now we have it saved. Now we can use it inside of our listen function. But first we want to fork. So we want to have one process per connection. So if we are still in the main thread, so to speak, we want to go to the next one. And we want to clean up a little bit first. This con we don't need to save, so con is equal to, free, let's say, if con, free con. And since there are two different processes, it doesn't matter that we free this thing. We can still use it in our other process because all of this stuff is copied automatically. So the code we put after this if statement will run in the child process of this, of this connection. So now we just want to return our handler. So let's see, we want to run con.connectBack. And what arguments do we have for our connectBack? The connection, okay? We want to run this with our con. And this doesn't return anything, no. exit 0, like so. So when we have handled the connection with our handler, we will exit this child process. But the main process will continue to accept connections in the background. And this should not be reached, but if in this case, let's just do exit 0. Return 0. All right. Okay, I think this is going to work. We also need to have this listen function here. So that is an int listen void, which we also need to set in our initialization function. So serve listen is equal to the address of listen. All right. So the only thing really that is left is our well, it's not much left actually. But we need to create some temporary handler function, so we know how to use this. Maybe we can have a method on the connection for sending and receiving data. Yeah, why not? So let's say we have an int receive, which is going to take let's see here. We can actually create a global variable for this too, which will only be used inside of the process, because we will only have one function for that. I mean one connection per handler. So let's say we have a public connection global con. Like so. So before we call the callback, we need to set those things. Global con is equal to con. Let's also set these methods. So we'll have a send which is equal to a send function, and receive which is equal to a receive function. The only thing we need to provide is char buffer and the number of bytes to receive, which is, let's do an int. And same with the send, like so. So we will have a receive function and those will be very simple functions. So int receive function, we have a char c, we have an int size, and we need to check that we have a global con. So if we don't have a global con, or we don't have a C, or we have a 0 size, if any of these happens, we'll just return an error like this. Otherwise, we will return the read system call. And we want to read from the global con fd, or what did we call the file descriptor? Fd. And did we copy it over? Yes. So we want to read from that as an integer. And then we just provide the C and the size, like so. And same with the send function. but in this case we want to return right. Like so. Very simple indeed. So let's just create some simple handler. Let's say we have a buffer. So char buff, I don't know, 128. So first we send something. Let's say welcome to server. Nineteen characters. And then we read something. So we receive into our buffer 127. And let's just print received. Something like this. Buff. So this is how the programmer using our library is going to use it. It will just use the send function, 2 arguments like this. And the receive function, 2 arguments. Very simple. Okay, that's pretty much it. Now we only need to fix any potential errors. Unknown type name connection at line 14. Okay, so I guess we need to move this down a notch. Here maybe. Warning, CTOR's attribute directive ignored. Okay, so maybe it's not CTOR's. Let's double check. Let's see here. GCC function attributes. Constructor destructor. That's exactly what I was looking for. Okay, so we need to type it all in. So it's not CTORs, it's constructor. Um, 18. Private init void start. And forgot to create this, so private void handler. It's a lot of errors, by the way, but probably a lot of them will be solved in one pen stroke. So let's see. Storage size of sock is not known. Right, we need to include a couple of things. So let's start with socket. And then we did bind. Then listen. Then accept. What else? We did aged on S. And we did inet ntoa. And inet address. We need string.h for memset. What about, maybe this is all we need. For the in the H file. Doot, doot. Right, this should be a pointer. So same here. Assignment to char void from incompatible pointer type char star star void. So either we should drop the ampersand or we need to add another star for this one. Let's see, 66. Let's see if this solves it. No. So serve R. It's this one. So maybe we need a star here. Yeah, it fixed it. Now we just need to do the same for the rest of them. Something like this. So why didn't it work this time? Weird. Listen. int star void int star int. Oh, listen is equal to listen. This should be listen function, right? Okay. Assignment to expression with array type. Con host. Is actually a char array, so we need to do string copy there. Here. So we need to put it inside of con host. We're gonna copy from this. $15. Okay. So let's see. Int star star. Int star. Connection has no member named CB. $141. Connection CB. Because the connect back function is not stored inside of that. Global serve. That's the one. This is just a typo. Private. This is a pointer, that's right. And now it compiled. I want to get rid of these annoying warnings though. Handler declared static but never defined. Right, this should be handler prime. Okay, so now all of these are just redundant privates. So let's remove those in our make file. I will just add a flag. So I paste this in, and after the W I will add no dash, no dash. Okay, so no, like this. And now, ladies and gentlemen, I think everything will compile. Yay! All right, let's try this thing out, shall we? Listening to port 8585. It did not fork into the background though. Let's see what happens if we connect to this thing. Welcome to server. And what if you type something? Foo. Received foo and some stuff. Kill all TCP server. Need to clean that thing out first. So let's see here. So it's inside of our handler. Before we receive, we should clean this buffer. So let's do memset buff 0 128. But why didn't it fork properly into the background? So let's see here. TCP server. Should be inside of the listen function. So we do the accept. Okay, we wait for the, no, wait. Here, fork. This should be the other way around, like this. Because we want to exit the main process. Which means that we probably did it the wrong way here as well, right? Because if fork is 0, then we are the child. This is the right thing. Weird that it worked anyway. Well. Okay, now it's forked into the background. Welcome to server. Foo. Received foo, new line. So it works. Pretty nice, pretty nice. But we want the connection to be closed when the handler function returns, right? So let's see here. Inside of our listen function. So we call the callback and then we exit. So maybe we should close this thing first. So we're going to close the S. Like so. That's weird. The address is in use. But why did it crash? It should print an error message, right? So let's see. What do we do here? This bind failed, which means we close down this thing and we return this error. And what does the return error macro do? Is it something wrong with this construction? We haven't set the function, the methods. That's probably why. So when we have allocated this thing and cleaned it out, we want to set the serve OK equal to the OK function. And we want to do the same for the error function. Okay, now it looks better. Does still work? Foo. Well, it works, but it does not close the connection. And we return from this handler. And we close S. And then we exit. So we close it and we exit, but it's still open. Why is that? So let's see here. So we read the foo, we print it, we close, and we exit. But it's still open here. Why is that? Maybe we need to close it on both sides. That's right. Where do we fork? Listen function. Down here. So let's close the S before we do anything else. Okay, now it works. Okay, we have successfully created a library. So I hope you liked this episode. If so, please like and subscribe. And thanks for watching. Thanks for today.